Hi, ladies and gentlemen, Mr. Green. I'm going to continue on with my lessons in statistics here. What we're looking at today is mutually exclusive or not, exclusivity. And so the best way to do this is just to give you an example. Experiment. We're going to choose one card from a bag of cards labeled 1 through 30. The cards 1 through 15 are red and the cards 16 through 30 are blue. You know what? I think the best way to demonstrate this is by using Venn diagrams. So I've got 1 through 15 over here in red, and I've got a Venn diagram over here with 16 through 30 over here. Okay? So you can see these two, just on their merits, there's nothing in the intersection between the two of them, is there? But we do have to say, when we're looking at what we're going to be doing, the event that we're trying to guess. And this one says, what is when you're choosing red card or a 20? Well, the 20 is over here in the blue section, and the red cards are here. So the actual group that I would have here is going to look like that. It's going to have all the reds and that 120 that's out of the blue section. So are these mutually exclusive now? No, not mutually exclusive. There is an overlap between the two of them. If I look at the probability of drawing a red card, that's 1 in 15. The probability of drawing a blue card, that's 1 in 15. But the probability of drawing a red card or a 20 is not going to be 1 out of 30. It's going to be something slightly different than that because there was an overlap. Okay? So let's look at the probability of choosing a red card or a multiple of 10. Well, that is a little bit different. Let's get rid of that. Okay. Here we're looking at multiples of 10 being in both of these here, in both sections. There's a 10 there, and there's a 20 and a 30 over here. And so my set that I would be drawing is going to be a red card, okay, but it's also going to include both of those two there. So in this situation, this one, once again, is not mutually exclusive. Okay? Where does this come into play? Well, if they are mutually exclusive events, you can just add the probabilities together to get the answer that you're looking for. If they're not mutually exclusive, you have to eliminate that overlap. Okay? So, looking at this again, in this environment here, that green is what I'm wanting to get. Okay? And this 10 exists both in the red group and in the group that we were wanting to pull out that's multiples of 10. And this one up here, the numbers weren't in both groups at the same time. The 20 is over here in the blue group and the red card's over here in the red card. So this one they say is exclusive. Okay? That's how come we can come over here and add the probability of getting a red, which is 1 out of 30. The probability of getting a 20, that's 1 out of 30. So 15 out of 30 plus 1 out of 30 gives you 16 out of 30, or 8 out of 15. Down here, probability of getting a red, 15 out of 30. The probability of getting a multiple of 10, that's 3 out of 30. But one of them was already a red card, so you had to subtract that one probability of getting that one red card out of both that was in both red and in the multiple of 10. And so you get 17 out of 30. So which is greater? This is a greater probability up here than this one down here. Okay? My pen think tool left me. This one is the greater probability. Okay? This would be more likely to occur than this one down here, than the bottom one. Okay? That's how mutually exclusive works. You just have to know how to add a little bit, add and subtract. And unfortunately, it's fractions. So I'm going to continue on. We'll be finishing up this unit shortly. Talk to you later. Bye.